I'm going to tell my short bio, so listen carefully. Okay, that's good. No, I went to college in Indiana, Wabash College in Crawfordsville, and graduated from Ball State University with a major in physics and geology and a minor in math. Took me 5 years to do that. Got out of college, recruited by a waterline company called Dresser Atlas. Went to Houston school, down there for a little bit, and then came back and worked out of Oklahoma in the field with logging trucks like this. Then I moved up here to what I told was God's country. God didn't show up that day, but you know. Good place to live. I'm from eastern Indiana, so it wasn't that bad in southern Illinois, but it's kind of flat. Gets a little boring, but it's a nice place to grow up and live. All my kids grew up there and everything. So, yeah, I'm married and have kids, and now I'm just a consultant, geologic consultant and log analyst in Evansville, Indiana, and I kind of do that for a living. I work primarily just in the field. I have a company of my own with a couple other guys, and then for a big outfit out of Houston, Texas called Citation Oil and Gas. So with that, if you don't understand something in this, I'm not going to hold anything against you. When I got into the oil business, I was as green grass in the spring. So that's kind of where I came from. Oil still existed in cavities and pools underneath the ground. So anyway, well, that's the wrong one, pointer. Okay, what is a wireline log? And then again, as I said, we're talking about not tree logs, but information that's found by running a cable, tools off of a cable down into a well bore. You've seen today, I assume, how a well is drilled and things like that, I take it? Okay. So these are just kind of, definitions. Society of Professional Well Log Analysts, SPLLA, defines the following: a record containing one or more curves related to properties in the well bore or some property in the formation surrounding the well bore. And then we have another one, the well log. It's a product of survey operation, also called a survey, consisting of one or more curves. It provides a permanent record of one or more physical properties as a function of the depth of the well bore. And I just simply call it a continuous graphic representation of the rock strata in the well bore. Pretty much means the same. So in the beginning, and that was around in the later 1930s and 40s, mainly in the 40s, started logging. And there's the first logging truck. French company, Schlumberger, of course somebody from somewhere else. And that's how they recorded data. There was a cable. They had two guys recording data with this cable hooked to those things and the tools running in a hole. And that's a representation of the first well log. This is a modern day truck, logging truck. It's Weatherford. There's a couple in the basin here, Weatherford and Geolog. And this is not the largest type logging truck, but that's basically what it's like. Looks like that. There's a bunch of stuff in it though. This is a recorder cab. Right in this part of the section of the truck is a recorder cab. You'll see later there's cable and other things in the back part of the truck there.
Pointed at the projector.
At the projector, okay. This is inside the recording cab. This is the engineer right here. You can see all these different panels, even the microwave, so you can heat up your coffee during the job if it gets cold. And you can see there's a window right here. It's looking back towards the rig. He's going to put his tools in about right there on the top of the rig. And this is other equipment. And just have a couple other views. This engineer here is looking at data, and he's looking at the same place where the tools are laying and will be put up in the well bore. Same guy. As you notice, this guy right here has all this stuff in here and one little laptop. It's how many panels you needed and places to put instrumentation. Well, you can see today this is all he has right here. There's a computer here, two screens to tell what's going on, and so he can do the functions to make the log look right. And that's about all there is these days. When I first when we first got into computer trucks, this amounted to 56K. Now, if you can imagine 56K on a computer, you're starting to date yourself like I am. Of course, now we can record a lot more information now because we have computers, storage capacity, terabytes, not kbytes. This is the back of the truck. This is a cable. It comes up here and goes through instrumentation so it can record the depth accurately where they are in the borehole. This pink thing is a source. In logging, different types of logging, we have different sources that we use to radiate the formation with radioactive elements, or I should say photons, and we record those measurements back at tools. And this is simply a simple diagram of how it works. That logging truck runs a cable that you saw to a sheave, and it goes up, then goes down into the wellbore. It goes up so you can bring all the tools up out of the hole and lay them down. And this is what it looks like in real life. There's a logging truck, goes up to the first sheave right here, to the second sheave, and goes down in the borehole. And this is actually the logging truck, again, is back over here somewhere. This is the cable coming up, and these are tools that are going to be put in the borehole. Now, that when they go in the borehole, they're taken apart and they're screwed together. So when at the end, what goes all the way into the wellbore is a rigid instrumentation. It's not loose like that. They're all connected together, so there's communication through the wire line to all these tools, and all the data comes up the wire line to the computers in the truck. Okay, there's two different types of logging environments. One of them is open hole. This is run right after the well is drilled. That's what you've seen so far. And there are logs, cased hole, run after the well is cased and cemented. In other words, they've gone and cased it, cemented it, so there's production possibilities later on. And there's different types of logs you run at that point. And just uses for logs, as you see here, the main use for a well log is to find out the nature of the fluids or the saturation. I don't know if you've heard much. There's a source rock. A source rock is where the oil has been generated from, and it's called a thing called cracked out of this rock and has gone upwards. And in most cases, fluids want to become less pressure, so there's more pressure down here and it's squeezed out and they all go up. And just the hierarchy of how fluid sits, if you put it in just, say, a container, it'd be gas on top, oil in the middle, and water on the bottom. So naturally, since we're looking for oil or gas, we finish a well right in here. And this, of course, is oversimplified. And then you have cap rock. And what cap rock is, it can be any type of rock. It's just impermeable rock. You probably heard about permeability today in cores and other things, but permeability obviously is the ease from fluid to move from point A to point B. So if it's impermeable, it does not allow fluids to move on up. So the oil is trapped. You've probably heard that term too, it's trapped. So that's where you know where to drill. This is the only equation I'm going to show you. All this information from these tools and everything is run into an equation to find out what the saturation of water is. Well, that seems kind of counterintuitive, the fact that we're looking for oil. But the way the tools work, they look for water and they find the saturation of what amount is oil, gas, or water in the rock. And this is the main number. SW is just the water saturation. So what we really want is oil, and it's given in percentage, 100% or 1. So the oil saturation is just 1 or 100% minus the water saturation. And some of the things in all the terms and everything, I guess something important to remember that oil is an insulator. It's non-conductive. And water is a conductor. So therefore, electrical current goes through water rather easily. I'm sure you don't want to be standing in a pool of water in your house putting your finger in the socket. Wouldn't feel very good at all. And so therefore, since water is a conductor, electric current flows easily. And that's how we do. We have one tool that we run in a hole that measures conductivity, and the reverse of that is resistivity. So if something is conductive, it's got water in it more or less, and if it has higher resistivity, it may have oil in it. But there's a general rule down here, and I'll show you a good example of it. Resistivity or conductivity reversed or proportionality is with the same porosity. Have you all heard about porosity today? Okay. It's just the percentage in a given volume of how many holes are in the rock. So if a rock has a certain porosity or a certain amount of holes, if you put oil in that system, the resistivity is going to rise because it's an insulator. It's non-conductive. If you put water in that porosity, the resistivity is going to decrease because it's a conductor. And again, some secondary goals, what you want to see. And again, it goes to another important key. In the oil industry, we're looking for rocks that can hold oil and gas. So we want to find rocks that have porosity. In other words, more holes and good permeability. Again, permeability is essentially how well can the fluid move from that point to that point. I mean, it may go like this, or most rocks, it goes like this. And that's just fluid moving through that rock, the ease that it moves through. And we have sandstones, limestones, dolomites, and I'm sure you heard about shale. The big ones being the Utica and the Marcellus in the east, Haynesville and the Permian Basin, Wolfcamp out there. A lot of different names for shales. These are just pictures of some of those rocks. I know it's hard to tell the difference by these small hand specimens, but this is a sandstone, this is a limestone, that's a dolomite, and that would be a shale. And these shales that we talk about as source rock are different from what the shales most of the time you see in road cuts. Shales that are in, a lot of times you see it is just mud and organic material that doesn't stay around. It changes, decays, and becomes mud, and then it's hardened. Organic rock is a lot more to do with critters and things in there which, when they decay, they become oil. Be a simple way to put it. And there's, again, different type of tools. There's electrical tools, again, which measure resistivity. And we're finding all these parameters to put in that equation I showed you back there. But we have nuclear tools. Again, these are ones that have sources, radioactive sources. And these radioactive sources emit gamma rays out into the formation. And the tools measure photons coming back, ejected electrons from these gamma rays. Then we have acoustical, so we have resistivity, you have nuclear, you have acoustical tools, again, which find out other different parameters. Acoustical tools you use a lot of times to find where the picture had the cap rock. It's a good tool to find out whether you have good cap rock. You can find attitude, how hard it is it limber, does it stretch, is it elastic, is it brittle? Find those kind of things out with a acoustical tool. Imaging tools, it's one of the things, again, with the advent of computers and the storage space and cache memory you have where you can process information very quickly. Electrical, nuclear, acoustical, you can image all these tools. In other words, there's tools where you actually have an image. And the image will be done by hard rock is a certain color, soft rock or rocks with porosity are a certain color. And that's how you distinguish everything in the wellbore. This is just an array of tools. Again, here's a rig. The logging truck would be out here somewhere. And this is just an assortment of tools. They're all not the same. They come different sizes. Some of them have pads on the side. Some of them have 4 pads on the side that are opened once the tool is in the hole. And this is what we're after. This is what's called a dual induction log, or Induction is a resistivity tool. And again, all this information is just telling you kind of what kind of rock it is, or perhaps maybe if it has oil or gas or water, what kind of fluid saturation it has. And this is a corresponding porosity log that goes with that tool. And again, it's looking for holes in the rock. So this is, right there is 0%, this is 30%. So in other words, we get out to this and what is it, 23%, 24%? That's per given volume, that's how much percentage of that rock has holes in it. So 23% of that rock has holes in it, which is very good. Because again, the more holes you have in it, the more space, the more holding capacity there is for oil to be in the reservoir or gas. And here's an idea, again, where the same well with those two different type of logs, the resistivity log and the porosity log. Again, this is conductive, this is non-conductive. So just looking at resistivity, we have low resistivity, we have higher resistivity, then we have real high resistivity. But it goes back to the porosity values. You have hardly any holes in this rock. You have a lot of holes in this rock down in here. And a while ago, I told you which is hard, but for the same porosity, in other words, you have the same rock, it has the same porosity, so it has the same amount of capacity to hold fluids. If it's an insulator, it'd be like oil. If it's water, it'd be conductive. And in the zone right there, we can see that on the porosity, it's the same porosity, same amount of holes. Over here we have low resistivity, and up here in the upper part of it we have high resistivity. So just by qualitatively looking at the log, we have an idea that we have oil on the top and water in the bottom. Just knowing that we have the same porosity without even knowing this, this water saturation or number which we have right here. In correlations, again, well logs are used for correlating, say from Seth, Gary, over to the other side of the room, say your well logs. You want to find out if, say, this rock goes anywhere. Is it just in the well bore you drilled, or does it go somewhere else? So we do close-in geology, which I call field geology. Wells are close together, 660 or 1,320 feet apart, and they go over maybe 1.5 miles wide or such. And then you have regional geology, where we go from, say, Mount Vernon, Illinois to Carbondale over to Carmi. We correlate the same formations. So that's shown like this is a field correlation. From here to here, it's 1.5 miles. And I have in red all the zones that correlate up together. And this is on a datum point. So this is down dip and this is up dip. And again, oil wants to go to the place of least resistance till it's trapped by cap rock. So these, if you had oil in these formations here, they could be oil saturated here and water saturated down here. Just because, again, water's on bottom, then you have oil, and then you have gas. And this is an example we're doing regional geology. And you can see these wells 28 miles apart. But if you look, there's some common things you can see that look the same on the logs. And one of them is this place where you have resistivity and you have porosity, and especially on the base. They look very similar. You have indicators that this is the same place, and this is the same rock as that rock, and it's 28 miles apart. Now, is there oil in those rocks, both different places? I don't know. But it gives you an idea how you correlate to find out where you might be. And again, things are deposited. A lot of people don't realize when things were deposited in the Illinois Basin, there was a 1/2 degree of dip. What I mean by dip, in other words, this would be exaggerated dip. This line. Well, things were deposited in water that were a 1/2 degree or a degree of slope. So in other words, you could start at point A and walk 300 feet, 400 feet, and the water may be up to your knees. Just a lot of people don't realize that stuff was just deposited level. So in this case here, you can correlate that this is the same correlation point. This one is that, and that is that, which means this total section of rock was not deposited in this well here. So if everything looks productive, like that one well did, again, not knowing any numbers, just by qualitative look, you set casing and cement it. In which case, you set casing and cement it so you can isolate different fluids. We use logs to see all these different strings of casing with the cement around them. There's logs to tell if it's cemented. Again, in the worst oil disaster in the Gulf that we had a few years back, it wasn't due to fracking, drilling, logging, or anything. It was due to cement quality. They didn't have not a good bond, what's called a good bond. So cased hole logs, again, you find there are different logging type tools because you're going through casing. And a lot of times that will inhibit resistivity, for example. You can see that pipe is very conductive. So you wouldn't have any kind of resistivity tool. But you want to correlate to your open hole logs, because again, what you're trying to do is be able to get the oil out of the well bore. So you have different kinds: gamma rays correlation, lithology, cement bond logs. The cement bond log is to tell if your formation is cemented from the formation to the cement to the pipe. And again, that's how the fluids are isolated from, say, rock at the top of the ceiling to rock at the floor, which is very, very important. And there's an example of a same well in this case. This is the information which is called a variable density. It has to do, you can get data from it to tell if there is casing to cement bond and to the formation, again, which is very important. And this is what's called a gamma ray neutron. And simply, gamma ray is another important tool. All it tells you, instead of sending radioactive gamma rays out into the formation, it records radioactive gamma rays coming into the well bore. And the dirtier the rock, say shale, you have heavier elements which contain more radioactivity. So it's over here, rocks that do not contain radioactivity, or cleaner rocks and are more or less reservoir rocks, where we could find oil or gas. And then we need to get the fluid. Once we have cemented it, or cased it, cemented it, run the logs where we know where we want to get the oil from. We have what's called, they're run on the wire line, they're called perforating guns. And this is really simple, but this is the way it looks like. You fire those guns, again, from the cable up to the logging truck, and it puts holes in the pipe, in the cement, and the formation, and these arrows indicate the fluid is allowed to move in from the well bore. And that's one way of producing oil or gas, and unfortunately water from different formations. Again, that's about all I have. Some people allowed me to use information in this talk, or there.